There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, silver, and samarium, and bismuth, bromide, lithium, beryllium, and barium. Isn't that interesting?
3, 2,
I hope you're all paying attention. There's
fire.
going to be a short quiz later on.
Okay.
There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury, molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, redenzine, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Okay, hello everybody. This is Chemical Charlie.
And I'm Pie Pepin.
And we're going to do a nice demonstration that you're going to see in a few minutes of the vapor pressure of solid iodine as a function of temperature. Iodine, the nice thing about it, its symbol is I, and iodine is a diatomic molecule, so it's I2. And it's got color, and the vapor has color. A lot of times you see water vapor and it's colorless, so you don't realize that there's anything there. But with iodine, you'll see it. You'll see the color. And like most solids, many solids have very low vapor pressures, but iodine is fairly volatile. So we have here plotted the vapor pressure, which I got from the internet, as a function of temperature in Kelvin, in Celsius rather. And as you can see, and the vapor pressure, by the way, is in millimeters of mercury. So 760 is 1 atmosphere. As you raise the temperature, the vapor pressure increases, but it never gets up. I mean, it does eventually get up to 760, and but it melts before it gets there. All right, so first the solid would melt, and then eventually the liquid would reach a vapor pressure of 760, and then that would be the boiling point. I don't know off the top of my head what the boiling point of iodine is, but anyway. All right, so as you can see, the vapor pressure increases with temperature, and therefore the intensity of the color above the iodine in the vapor phase should get more and more intense as you go up in temperature. And if you go from a high temperature down to a lower temperature, it should get less and less intense. So anything to add? I think that's probably about all we have to say. So we'll be showing you the video of the heated iodine as a function of temperature.
It is sped up 64 times.
Okay, hello again everybody. This is Chemical Charlie.
And this is Pie Pepin.
And this is our video showing the vapor pressure of solid iodine. So here we have iodine solid, which has been heated to a high temperature, and you can see as time goes on the color gets less and less bright. This is actually speeded up by a factor of 64, but you can see that it gets less and less bright.
And you can see that it moves.
Yeah.
So here's the warm iodine.
See how the purple color of the iodine vapor?
You may not have noticed it, but the cool iodine looks slightly different.
There's the cool. Well, I would say
very different.
Very different. Thank you for